2.5. Okay, direct variation. All right, now, all right. When two variables, we'll call them X and Y, vary directly. In other words, they have a direct relationship, okay? If there is a non-zero number, and we'll call it K, the following is true. Okay? Y equal KX. All right, now we're talking about K, and we'll put a number in here in just a second, okay? And that's what we got to describe. The number K is constant. Let me rephrase that. Is a constant. Okay, in other words, it's a number. Okay, it's the constant of the variation. And basically what they're saying is this. If you have this, y equal 2x, okay, or y equal 1/2x, all right, the constant right there is the slope. Okay, so the slope of y equal 2x is 2. The slope of y equal 1/2x is 1/2. Okay, if it was negative 1/2, like that, then the slope would be negative 1/2. Okay, whatever number, constant, okay, it's a constant, we call that a number, is the constant, is in correlation is the slope. Now, if you just had 22 equal 2x, okay, well, that's not even the same situation. Okay, it's not even the same type of equation. It's not even, that's totally different than y equal 2x. Okay, now, it is the slope, but okay, the type of line that type of equation represents is a line that goes through the origin. In other words, if I have a graph, okay, this type of line, okay, it goes through the origin. When you see, for example, this might be y equal 2x. Okay, because there's no other part of the equation here. In other words, we're used to seeing equations that look like this. We're used to seeing y equal 2x plus 3. Okay, but now we don't have this part. When you don't have that part, eventually they will call it the b. Okay, eventually we'll get this whole thing and they'll call that the b part. Eventually they'll call that b. When you don't have B, that means you don't have a y-intercept. So it can't cross the y-axis. Okay, and when it can't cross the y-axis, then it has to be going through the origin. In other words, we said the other day that the y-intercept, the x-coordinate on a y-intercept was what? It was what? 0. Okay, so if I have this equation then, if I have y equal 2x, and I say that x is equal to 0 to find out what the y-intercept is, well, that means I plug in y equal 2 times 0. Well, then if x is equal to 0, y would be equal to 0. And so this then means our coordinates are 0, 0. Well, on a graph, 0, 0 would be right there. That represents 0, 0. Okay, now, how do you find the slope given, for example, y equal negative 3x? If you have to prove the slope, if you have to prove it, well, we need two values for the slope. So we're going to do our input-output table, and we're going to do the same thing that we did the other day. We're going to make x equal to 0, and we're going to make y equal 0. Okay, now, let's see here. No, not going to do that. Not going to do that. They're going to give them to you. Let me make sure. Yeah, they're going to give them to you. Okay. Bear with me 1 second. I want to make sure I give it to you correctly. Yeah, okay. All right. They're going to, well, bottom line is, we said the slope is what in that equation? Negative 3. Okay? So the constant variation in this equation is equal to negative 3. The slope is equal to the constant variation, so the slope is equal to negative 3. It's the same answer for both of them. Okay? What they're going to do to get you to solve equations, that's the easy part. They give you the equation. I think they're just going to give basically, they're just going to give you a bunch of equations. You tell them the constant, you tell them the slope. Same number. Where it gets a little bit more difficult is where they do this. X is equal to 4, and y is equal to 12. Okay, and they want you to first write an equation for that situation. Okay, well, the equation's easy. It's 12 equal k times 4. Okay, because we said earlier that this is our direct variation model. Okay, and so all I did then is I plugged in the 12 for the y and the 4 for the x. Now, I've got to solve that to find out what k is. Okay, so the first part, write the equation. Second part, solve the equation for k. Okay, just like we've been doing. To solve that, we just simply divide by 4 to both sides. So what's k equal to? K is equal to 3. Okay, so since k is equal to 3, then the last part is write an equation that write an equation that relates x and y. So now we're talking about functions. We said a function is y equal x and a blank. Okay, we talk about functions. Y is equal to 3x plus 2. Y is equal to 1/2 x plus 5. Okay, but since this is a direct variation, we know then that y is equal to 3x. Okay, and that is your actual answer. Okay, this is the process. All of this is the process to get to that answer. Okay, let me do another one for you. X is equal to 22 and y is equal to 11. Okay, so they want us to take this and go, okay, 11 is equal to k times 22. So what's k equal to? 1/2. Because I've got to divide by 22, divide by 22. You took the 11. If you said 2, you took the 11 to the 22, and that doesn't get k by itself. Okay? So, then my function is y equal 1/2 x. And that's my answer.
So your answer is in function form?
Yep, an equation that relates x and y. And what are functions? Functions are a relationship between two things. Okay, and so that's why they say relate as a function. Do this one on your own. This one's a little tougher. X equal 7 1/5. Y is equal to -9. Okay, you can leave your answer in improper fraction form. Yes. Because as I stated earlier this week, when we're talking about functions, we're talking about slope, anything like that, anything dealing with linear equations, we always leave our improper fractions as improper fractions, not mixed numbers. All right, who has an answer? Going with Zach. Matt? Yes. Y is equal to -5/4 x. Okay, now, Make sure we understand how we got that. You plug in -9 equal K times 7 1/5. Now, 7 1/5 I have to change to 36/5. Okay? And that's equal to -9. Now I take and do the reciprocal. Multiply by the reciprocal to both sides. That cancels. Over here, that's 9/1, which means I can take 9 into 9 one time, 9 into 36 4 times. So that'd be 5 times 1 on top, -1, 4 times 1 on bottom is equal to K. So K is equal to -5/4. Then I translate that into my function, and that's y equal -5/4x. And that's your answer. Yep. Okay, everybody look at problem number 32. Page 238, problem number 32. Huh? No.
6th grade honors.
No. Nope. All right. Larry, you're real random today, sir. Number 32. It says the volume V of blood pumped through your heart each minute varies directly with the pulse rate of P. Each time your heart beats, it pumps approximately 0.06 liters of blood. Okay, so A says find an equation that relates V and P. So we want a function or relate of V and P. Okay, don't make this harder than it is. Okay, what would be an equation that would relate V and P given the information they gave us? Caleb? Yeah. V is equal to 0.06 P. Okay. Now, we are going to take our pulse. Okay. And we're going to do it for 10 seconds. Okay. Then we're going to multiply by 6. All right, so everybody get ready. I'll get my timer. Got it? All right, everybody found it? Then you're dead. So it won't matter. Right here. Do that, or you can go on your wrist. I can't. I have a harder time on my wrist than I do my neck. But you can't be talking, or you can't really feel it. So, Shelton, you might want to go to your wrist. See? I told you. Yeah. Okay, I'll slap you later. All right, ready? Go. Stop. All right. Now, so if your heart rate for 10 seconds, mine was 10. So mine was 10 beats. So that means I had 60 beats per minute. Okay, so now you figure out yours, and we're gonna take it here and go 0.06. So mine was 60 beats. So I'm gonna multiply by 60. And so the volume of blood mine comes out to be is 0.36 liters. Well, mine you can just take and 0.06 times. Oh, mine was 3.6. My bad.
Okay.
3.6 liters. To find how many beats per minute you had?
I had 90 beats per minute.
Huh? No, you don't. No. So y'all are wrong. Multiply by 6. Because there's 60 seconds. So if you did it for 10 seconds, you multiply it by 6.
I got 5.4.
So when it comes to heartbeat stuff like that, I don't ever know, because it varies by your age and your weight. Huh? 70 to 90? Well, then none of y'all are normal. No, I'm just joking. Most of you are. All right, so you take the number of beats, multiply it by 0.06, and that's the amount of that's the liters of blood, approximately liters of blood that pump through your heart in a minute. Okay? So you look at liters. Liters is very similar to a gallon. Okay? So, like for me, it was, almost 4 gallons. It probably is. It's probably about 4 gallons per minute. It's a lot of blood. Okay? Now, no, 7.8. Or what'd you get? Shouldn't got point something. $13 beats times 6. 78 beats per minute. All right. Now, everybody turn to page 236. Turn to page 236. I want you to look at example 4. Now, hey, zip it. Now, understand that the direct variation, the y equal k over x, or k times x, can be written as a ratio. Okay? The ratio would be k equal y over x. The reason being is if you want to solve for k, then we would divide by x to both sides. Okay, and so this is how we solve for k. It is also a ratio. Okay, so if we look at the alligator example, it says the tail and body lengths in feet of 8 alligators are shown below. The ages range from 2 years to over 50 years. All right. Now, I believe that the ages, for example, 1.41 for the tail and 1.50 for the body is the youngest one, obviously. Okay? It's not a Benjamin Buttons deal where they, where they're born as a full length alligator and then they shrink down as they grow old. Okay? So, if you look at that table, it starts at 2 years and the very last one would be the 50-year one. Okay? It says, Part A says, write a model that relates the tail length to the body length. All right? Relates the tail length to the body length. You will see that table in the second part where it says solution. Okay? Basically what they've done is they created a ratio, tail length on top, body length on bottom. So they put, for that first one, 1.41 over 1.50. And that's where they got the 0.94 in the table. Okay, and then the second one, they went 2.04 over 2.41, and they got a ratio of 0.85. Okay, that's how they got it. Now, the second part says estimate the body length of an alligator whose tail length is 4.5 feet. Okay, 4.5 feet. Now, if you go down to the tail length of 4.5, or the one that's closest to it. Which one is closest to it? 4.67. Okay, is that 4.5? No. So we're going to take the ratio. In other words, they give us this, 4.67 over the 5.04, and that was equal to 0.93. Okay, so what they're going to say is they want 4.5 feet. So if 4.67 was 0.93, then 4.5 we can say was probably approximately 0.9. Okay, so the tail length then would be equal to 0.9 of the body length. So you plug that in, and that would be the tail length is going to be equal to 0.9 times the body length was 4.5 feet, or excuse me, the tail length was 4.5 feet. So we got 0.9 times the body, and the tail was 4.5. I thought they gave me the body, but they gave me the tail. So that's how you would find out what the approximate body length was. Okay, when you solve that, obviously the answer's in the book, so I'm not going to go into great detail. Okay, when you solve that, you get 5 feet. In other words, they did this. They did that right there. Take 0.9 and divide it into 4.5. And it's very simple. Move this once, move it once, 45 over 9, which is 5. So the body length is approximately 5 feet. Okay? So that's how you can take a table and come up with approximations, and a lot of times it won't be approximations, it'll be exacts. Okay? Now, I am not going to assign homework because of, some of the football guys and going to Munster. Okay? So we're going to do it in class tomorrow. What we're going to do in class tomorrow is 4.5 1 through 33, And then $38 through $41. If you do it tonight,